Hi guys, welcome to experiment 9, acid-base calorimetry. Okay, we're working on energy and we're looking at the energy released or absorbed during a chemical reaction. Okay, so the reaction we're doing today is HCl aqueous plus NaOH aqueous going to H2O liquid plus NaCl aqueous. This is a strong acid-base reaction. Okay, strong acid-base reaction. Now, in this reaction, we're going to be measuring the amount of energy released, this is an exothermic reaction, from this chemical process by looking at the change in the temperature of the water in which the reaction is happening. Okay? So let's talk about this for a second. We know that Q of a reaction is equal to the negative Q of the water. So the Q of the reaction is going to be the negative of the mass of the water times the heat capacity for water times the change in temperature for the water. Okay? The mass of the water is going to be based on the volume of water. The volume of water that you're dealing with is going to be 45 milliliters, so your mass of water is going to be 45 grams. Okay? Now, you're also going to need to have your moles of HCl, which is going to be your molarity of HCl times the volume of HCl added. And remember that volume needs to be in liters. All right? So what you're going to do then is you're going to get we're going to have 3 beakers. We're going to put 25 milliliters of NaOH in there, that's 2 molar. And then we're going to add to it 20 milliliters of a 2 molar HCl solution. The HCl is our limiting reagent. Okay? So that when we perform the reaction, when we get this Q, it'll be for this specific number of moles of HCl. And when I take my Q of reaction and divide it by my moles of HCl, it's going to give me the delta H of reaction for this guy because there's 1 mole of HCl in here. And when I divide Q by this, I'll get energy per mole of HCl. And you're going to repeat that 3 times and get the average value. Okay? And then you're going to compare it to the actual value for the delta H of this reaction. Now, you're going to work this out, and this is going to be in joules. Okay? The delta H given is minus 57.62 kilojoules, or that's a minus 5.762 times 10 to the 4 joules. Okay? Just in case you've forgotten how to convert from kilojoules to joules. All right? So let's get to taking our data. Okay, now here I have a coffee cup which I'm using as a calorimeter because it's insulated, and when I nestle a beaker down in there with some paper wrapped around it, it's going to be fairly well insulated and it's not going to exchange energy quickly with the environment, which is what we want. Okay, so I'm going to take a beaker and I'm going to wrap it in paper towels, and I'm going to nestle it inside the coffee cup. So you can see it's nestled inside the coffee cup. All right? Now, I'm going to take its temperature. In the coffee cup, I already have NaOH, the sodium hydroxide. Okay? And the temperature of the NaOH is 22.0 degrees C. Now, I'm also going to take the temperature of my HCl solution. Since it's been sitting out in the same room, okay, it's reading 22.1 degrees C. Okay? They should have been the same, but it could have been that I left a little bit of base on the NaOH, and it could have reacted with a little bit of acid and changed the temperature just a hair. But I'm going to put it back in my NaOH solution. Now I'm going to pipette 20 milliliters of HCl. Okay. Now I'm going to release it into the chamber. Okay, notice that the temperature of the solution is going up as the reaction happens. We're going to wait until the temperature reaches its highest point. Still climbing. Gone up to 32, 32.1. Okay, so our highest temperature reached is 32.1. Now, the average between 22.0 and 22.1 is 22.05, but I can only go only have 3 significant figures. So I go 22.1 as my initial temperature. So I had a change in temperature of 10 degrees. Oh, yeah, 10 degrees. Okay, so we're done with that beaker. I pull it out. I get rid of it. And we reload. So the next beaker gets inserted. It already has 25 milliliters of NaOH in there. Measure out my HCl. Well, our HCl. Okay, start draining it. Put the thermometer in, and away we go. Okay. Okay, on my second run, the highest temperature I saw was 32.5. Now you guys can look at the film and you can figure out if you saw something different. Okay. Okay, so I can pull that beaker out. Now the last beaker goes in. Get my thermometer all set. Pipette again. And we're to our last measurement. The temperature climbs as we add in the HCl. Okay, let's stir. Look for our highest temperature. Okay, the highest temperature I saw was 32.2 degrees, 32.3 degrees C. Okay, so you now have all of your data. Your initial temperatures and your average initial temperature is always the same. You can calculate your change in temperature for each case, calculate your delta H, get your average, and calculate your percent difference. Remember to have a completed data sheet and email it to me. Remember, all your data sheets are Word documents, so you can just go in there and type all your numbers in, okay, and then email it back to me. All right, guys, one more lab down.